Good afternoon, everyone. Thank you for coming out to DataEngBytes. Today we'll be talking about testing and automated testing, which might be verbal melatonin at 4:30. So I apologise if you fall asleep, but I hope to keep you somewhat entertained. I've already been introduced, so I don't have to do that, thank God. But the title of my talk is Trust but Verify, Ensuring Data Quality with CI/CD. Cool. So what am I going to talk about? I'm going to quickly tell you what CI/CD is. Can I have a show of hands who actually knows what CI/CD is? Cool, so I'll be preaching to the choir. Cool, thank God. I'm also going to go over some types of testing, some implementation patterns, and some considerations, as well as talking about notifications. So, cool. CI/CD, it starts for, oh Christ, sorry about that. CI/CD stands for Continuous Integration and Continuous Delivery. Continuous integration is the process of merging data engineers' working copies of a common project. And continuous delivery is the automated process of testing that, or testing the changes in those common projects, those working copies, and then deploying those changes into production. This is what it looks like at a high level. So you've got data engineers making their changes, pushing them into GitHub, which is continuous integration. Then something like GitHub Actions or Circle CI or CodeFresh or something like that uses YAML to push those things into production. Cool, so from a data engineer's perspective, this might look like creating new DBT models or tables, for example. Or maybe you've spun up some infrastructure for your Snowflake instance, and luckily you've got it in code. But you want to get these changes to the common project or the production project. But you've also got to manage everyone else's changes in that common project. Well, this is continuous integration. And within continuous integration, you've got things like pull requests, which are requests for change, which generally get looked over carefully and approved, or someone blindly comments, looks good to me, and gives it the tick. Once that's happened and the changes have merged in, as I said, GitHub Actions or something similar pushes those changes into production. And that's continuous delivery. Cool beans, all right. I'm gonna go over 3 types of testing today: end-to-end testing, non-functional testing, and data quality testing. Starting off with end-to-end. So, let's imagine that you've got some transformations that calculate a particular metric for C-level reporting or something similar. In this case, let's think about profit. Say 1 month you calculate profit in a new way and you come up with $1 million for that month. And your boss, this is my boss actually, I kept forgetting that during the rehearsal, so I had to put this slide in. This is my boss. He says, wow, I am so happy. But then he says, wait a minute. I've got negative $200,000 in my bank account, Matthew. What are you talking about $1 million profit? Well, one of the reasons this can happen is that transformation that I worked on all month is actually on fire. And now I've got to rush off and try and figure out what the hell's going on. So one way we can mitigate this risk or avoid it happening is with end-to-end testing. Who here has inherited a stored procedure that's about 8,000 lines long of SQL? You don't actually know what's going on, and the business relies on it maybe? Cool. So end-to-end testing or black box testing is something that you can use to put guardrails around those stored procedures. You can mock input data, check the output of that stored procedure against what you're expecting it to output. You can think about this as putting in raw ingredients into this system and making sure what you get out is correct and that the customer is happy and that your boss is happy, which I'm told each and every day is the objective. So the tools that we can use for this, which I'm going to go over here, are PyTest. I think PyTest is great because in my experience, most data engineers know how to use Python. Is that a fair comment? Cool. The example I'm going to go over also has a bit of BDD sprinkled in there. If you don't know what that is, that's behavioral-driven development. And in particular, it's a gherkin test. Now, gherkin testing generally makes me feel like this. Pretty uncomfortable about it, but it works well for this example. So what is gherkin testing? Well, there are 3 statements in a gherkin test: given, when, and then. Given, some sort of setup. When something happens, then I expect this to happen. The example code that I'm going to go over is this test here. So given a user is opted into both email and mobile marketing, when they opt out of email marketing, then they will be opted out of email and still opted in to mobile. So this is what it can look like in code. So a given, when, and then statement. This is our basic setup, and you can think of this as our ingredients that I mentioned earlier. Here is where I'm checking the expected output versus the actual output. And we're going to pretend that the utility function here I'm calling that passes in our test data is really annoying and really complex. We don't actually know what's going on. And for this test, we don't actually necessarily care what's going on. We just want to take what it gives us back and check it against the expected output. Zooming in on one of these setups, you can see here that we have the business logic, the example data, and that target table there in which the test table is going, that test data is going, is in our test environment. Now, I just want to touch on a test environment in case you don't know what it is. A test environment is distinct from your development and production environment and is generally really similar to your production environment. It is a place that you first deploy changes to check that, or will check or test that they have worked. Now, zooming in onto this final then statement, I just wanted to touch on what this is doing for, I think, the third time now, but it's basically calling the stored procedure and pulling back the result of that stored procedure and checking it against what I'm expecting to get back. So this is using a stored procedure for a transformation, which I wouldn't necessarily recommend. And if you have the option to build it, like a greenfield, maybe something with DBT, I'd recommend using the available programmatic invocation, which I discovered in researching this talk, where you can actually call a DBT CLI command from Python, and you can pass in a target environment of test, as well as the target transformation that you're using. I think it's pretty cool. So, back to the example where I talked about your friend, or my mate in this case, blindly commenting looks good to me on your PR, and it going through. Instead, we can actually put our end-to-end tests here and ensure that business critical functionality isn't accepted by my blind faith, or my mate's blind faith. But I also wanted to go over some considerations or some gotchas. If you mock your test data with no rows in it, which sounds really silly, but it's pretty easy to do, and you have a minus statement in your final test where you take your actual output and you minus your expected output, if your input tables are empty, that means your output's going to be empty. If you minus using a SQL operation of minus, you get nothing back. And if your tests pass, when nothing comes back, you have a false positive error, which I've seen happen multiple times now. It's not just me, thank God. But one way to mitigate this is with watching your test fail, which is a lesson learned from test-driven development. Basically, I think that when people implement this, you're generally testing transformations retrospectively. And that's fair enough. But I would highly, highly recommend if you do this to make sure that you actually mock incorrect data and watch the test fail. So then you can have confidence that the test is behaving in an expected manner. And you do have to manage these tests because they are bespoke. Cool, so I'm going to go over the next type of test, which is non-functional. Has this ever happened to you? You make one change to your infrastructure and suddenly people start yelling, getting lots of emails, shout out Snowflake Terraform provider, if anyone gets that joke. No? Cool. Maybe this is a bit more relatable. Say you have an employee who is malicious or has become disenfranchised with work, and he raises a PR to give himself some elevated privileges within our RBAC. If you don't know what an RBAC is, it's a role-based access control model, but all you need to know is the closer you are to that bottom icon there, the more access you have. So say he raises this PR to your infrastructure as code, and then he gets one of his scaly mates to approve it, and suddenly you're up shit creek or something similar. How can we stop this? How can we lock down our security model? Well, enter non-functional testing. Non-functional testing involves testing things like your access control, your privacy data, your masking policies, things like that. Depending on how custom your implementation is on Snowflake or GCP, for example, you can use PyTest. I bet you're noticing a theme there. But in this case, I'm using just pure elbow grease. This is pretty bespoke how we did it. I'd also like to share an anecdote from our internal Slack where someone raised a PR that was modifying our RBAC, which is something generally I think is quite static. Once you've defined your access control, it's not something that you're going to manipulate a lot over time. You might make some changes, but they're generally pretty minimal, at least in my experience. So this happened in our internal data platform. Someone raised a PR that changed the RBAC, and the pipeline threw it back at us and said, nah, your test says this can't happen. But how do we do this in our test? Well, we defined our RBAC in code. This is the particular parameterized PyTest function. And you can see that we have each of our roles here and what they inherit from. In our test, we then go through each of the roles, check that the inheritance structure is correct, as well as that the correct privileges on it. You can go crazy with this, and you can kind of take a current state out of Snowflake or GCP and say, okay, this is what my current state looks like, and write all the tests for it. And I'm sure you can get an LLM to do that, but passing in your security model to an LLM is probably not a great idea. So where do we put this? Well, I would recommend putting it in your CD part of your CI/CD, in your continuous delivery. So once a PR has been merged, I would recommend deploying your changes first to test, which I mentioned earlier. Making sure those changes haven't broken anything, like broken your security model, and then pushing those changes into production. For this example, I have to thank Brian Yu. Is he in the audience? I think he's somewhere in here. Yeah. Brian's a senior at Mechanical Rock. He taught me most of what I know, along with a couple other champions at the workplace, but he wrote the code for that example, so I had to give him credit. The third type of testing I'm going to talk about is data quality testing. Has this happened to anyone? Your source system hands your data platform some data. Your data platform hands it off to your reports. Everyone comes back and says, this is null, what the fuck? I'll give credit to these people who might have actually stolen the meme, but I'll give it to them. Or has anyone dealt with this for longer than they'd like to admit? Maybe you have a query with about 10 CTEs or 10 subqueries, one of which is doing an inner join, and it's inner joining on a month that doesn't have any data in it, and there's no checks and balances to check if any data's come in for that month. And you're sitting there going, what the hell? I just want to go to lunch. What the fuck's going on? Well, one thing you can do to mitigate this is data quality testing. These involve tests for things like freshness. When was the last line of data, or when was the last data point to come through my pipeline? Types, making sure that the type of data coming through my pipeline is correct, and nulls. This is a bigger list of the ones that I use. It's certainly not exhaustive, but I like them. Things like uniqueness, accepted values, regex types, and a data contract, which was touched on by Chad. So the tools that I would recommend for this are Soda, DBT, Great Expectations. I wouldn't recommend Python, because Python is something that you have to build the tests for, like in a bespoke and custom way. And if you can offload the actual building of the tests, you don't have to worry that they work. So things like Soda and DBT are really good for that. This is what a data contract looks like in DBT. Unfortunately, different from what Chad showed us this morning, you can't like tag people in GitHub with this, unfortunately, although that would be really cool. But you can ensure that your data models in DBT are not built unless they adhere to the contract. So here you can see types and nulls being enforced here. And I've also got accepted values up there, but they are for data tests, not data contracts in DBT. So I wanted to show you a bit about Soda as well. I think Soda is awesome. This is the configuration for a Soda project. It's pretty minimal. It's very easy to set up. And these are some of the checks you can do. So this is things like freshness, accepted values, and required columns, which we experienced, I think, last month, where we had a source system rip the rug out from underneath us. And they told us they did it, but they didn't say it loud enough, so we didn't do anything. Well, no one picked it up. We didn't have Soda on it. And Soda's really good. I just want to make this point because I don't think I have a slide for it. But Soda's awesome because you don't have to rebuild your transformations, for example. Something like DBT, if you want to use DBT for testing, you have to have your transformations in DBT, whereas Soda is something you can bolt on. There's obviously risks involved with bolting on another tool into your data platform, but I think it's pretty cool for that reason. So where does this sit in CI/CD? Admittedly, it probably doesn't, but it does sit really well in your production pipeline. So say you've got a pipeline orchestrated with Dagster and Airflow, and you've got your input data that you just don't really trust, and it's a bit of a dumpster fire. But once your production pipeline runs, and you have these tables that are built in production, then you can run these data quality tests on things like Soda and DBT, and then throw up a flare if something's wrong. And I think this is where the magic happens. Cool, so Matt, do I really need any of this? It's a fair point. Testing kind of sucks. At the risk of like contradicting my whole talk, testing is really annoying. But it's kind of like eating your vegetables, right? It's something you should do. I think it saves time. I think it stops firefighting. I think it helps build trust. The biggest anecdote that I tell myself to get myself to write tests is that I trust what I do, generally, but I don't trust the next guy that's going to come along and manage my work. And putting checks and balances and tests around my work ensures that the next guy who comes along can still adhere to those dependencies or to those boundaries. You have end-to-end testing, making sure C-level reporting or complex transformations that involve business logic are still correct. You have non-functional testing, making sure that people don't have like write access to your production tables. If you do have write access to your production tables, congrats. I'm very jealous. And data quality is there to ensure that things are consistent. Some considerations I'd like to point out. The first one is time, both yours and the pipelines. Your time is obviously super important and you can go crazy with testing. I saw the sentiment posted online somewhere about if you don't have 100% test coverage, it's a security risk, which I think is dogmatic and not smart. I think there's some sort of 80-20 rule that you guys can figure out internally specific to your business needs that mean that the critical functionality is being tested and everything else you can kind of roll with the punches or get around to it when you've got time. Speaking of time, the pipeline's time. You've got to make sure that your pipeline is completing its checks and its deployments within an acceptable time frame. It's not great waiting 20 minutes for your PR checks to go through. That sort of feedback cycle really sucks. But it's ultimately up to you guys and your own business. The second thing I really want to hammer home is ensuring that tests are correct, especially the bespoke ones. It is headspace, it is operational overhead that you've got to manage. Watching those things fail, I think, is extremely important. Cool, so I just want to go over notifications next, and I think there's two questions involved with notifications. The first one is, what should I be notified of? And the second one is, how should I be notified? So, what should I be notified of? Probably not this. These checks, I'm recommending them going on a PR request. There was a conversation, or there was mentioned by Chad this morning about data contracts tagging people when they are violated, which I can concede is probably good, but I didn't prepare this speech today, so I didn't have that information, but that sounds pretty good to me. I think that notifications should definitely go on non-functional testing, even if it's a mistake. Like if your security model is trying to be changed by someone internally, I think that's enough of a reason to throw up a flare. I also think that data quality tests should be raised. Data quality test failures should also be raised, but the degree to which you do that is obviously up to you guys because it's very easy for this to happen. I'm sure someone's got emails that come through or a Slack channel that they've muted because you've got notification fatigue. It turns into white noise and you turn it off. So just to emphasize this point, say this is a toy diagram of a data platform. You've got Fivetran pushing data into Snowflake. You've got DBT messing it around and throwing it out to ThoughtSpot. Say Fivetran catches fire for some reason. I want to know about that. I want to know about Fivetran. I don't want to know about the 20 different DBT tables that have now broken. I just want the one notification, which is admittedly hard to do, but I think with enough elbow grease and error logging, I think you can get through it. Because your Slack notifications blow up, people fall asleep at the wheel, and suddenly you might have a lot of errors just slipping the keeper. Cool. I'd also like to go over where to post these notifications. I don't think email is the best one. At least I don't check my emails as often as I should. It's obviously very specific to each company, but I just wouldn't recommend it personally. I think if you're using Slack or Teams, those are far better places to put it. These are two integrations that exist. They don't have a lot of stars, which a lot of people are a bit scared of, but they both accept post requests, which I know people like. If you're a data person you don't like or don't know of post requests, just call up one of your software engineering buddies and tell them to come write the code for you. I'm sure they will happily oblige. Cool, so wrapping up, testing types I think that should be included in CI/CD and your production pipelines are, what did I just talk about? End-to-end testing, non-functional testing, data quality testing. Considerations, your time I think is the most important one, watching those tests fail, and notifications going to Slack and Teams. Cool. My name is Matthew Carter. I am a glorified Excel jockey that calls himself a data engineer and I work for Mechanical Rock. Thank you to Hamish for employing me. Thank you to Andreas, Z for telling me everything that I've ever known. Thanks, Jack, for getting me the job. Cool.
Thank you, Matt.